We're live. We're going to get started here. Thank you all for coming today. I'm Matt Snyder. I'm a PM on Service Fabric. I've been a PM on Service Fabric for about 5 years now. So I love this stuff, and I'm excited to be able to talk about it here for you guys today. We're going to talk about service orchestration with Service Fabric. First, we're going to talk about kind of what orchestration is and what it's good for, in case people aren't super familiar with it, though it is a term that's gaining some traction. It's out there pretty prevalently now. We're going to talk about Service Fabric and the orchestration capabilities that it can give to your services, and we're going to have lots of nice demos. So I'm going to show you how to do some of this stuff, then we're going to just wrap it up. So most of it will be explaining stuff and demos. So let's talk about the orchestration opportunity, right? So you have this very interesting world right now where you have a whole lot of different problems, right? You might want some leader election, you need some rolling upgrades, you need some resource governance, you need all sorts of stuff, density. In order for you to actually run your services at scale, you need some or all of these things. And just as expected, there's a lot of different solutions out there that solve all or part or some of these problems. However, there's a little bit of a downside to this as it sits today. The first is that the world actually looks like this, where you need some of the things on the right side to make some of the other things on the right side work, and there is no single thing on the right side that maps to all of the problems. So you end up cobbling together a whole bunch of different solutions that solve different parts of things, and then you have to manage this, and this makes people do things like this, where you just start going crazy, and you don't know what to do, and you have to have 5 experts on hand in order to really make anything work. So Service Fabric is a solution that solves all of these different things, all of these different problems that you might have. You might not have all of them. You might have some of them. But we let you take the parts of Service Fabric that you need and use them to solve those specific problems that you probably have on the left side. So, for those not familiar with Service Fabric, there's been a whole bunch of other sessions on Service Fabric at Ignite. I'll give you links to them at the end. If you haven't seen them, you can go watch them. I'm not going to spend a whole bunch of time on the Service Fabric basics here because we have a lot to talk about just in terms of orchestration. But basically, Service Fabric is the orchestration and high availability technology from Microsoft. It runs all sorts of different workloads internally. Everything from SQL Azure to DocDB to Cortana is all powered by this. We manage hundreds of thousands of machines, tens of thousands of workloads. As far as an environment abstraction layer goes, we work on basically anywhere today that there's a Windows OS, and we're going to be moving that to Linux in the future. So all these capabilities are pretty much available regardless of your environment and regardless of what particular problems you're trying to solve. Service Fabric is one integrated runtime that delivers all of that. So just some numbers to back this up. You can get a single Service Fabric cluster up to thousands of machines, thousands of nodes. You can run tens of thousands of workloads on a node. If you can get that dense, then we will support that. We can detect and do failovers and leader election in seconds. And you can deploy and upgrade your service in minutes because fundamentally we abstract you from that underlying OS. So instead of managing VMs, you're managing your applications, your services, and we give you the tools to deal with that. Now, why is orchestration interesting in this environment, right? Well, when you have, say, 10,000 machines or 1,000 machines, and you have 100,000 applications, and you have 100 services each, and they all have 3 or 4 replicas, different copies themselves for HA, you have billions of things. And they're all, this microservices architecture means that you have billions and billions, tens of billions of things. I did a quick piece of math on how many little replicas, how many objects are running around in probably your average SQL Azure deployment, and it's 10 to the 10 to the 5 point something, and the numbers get so big that you can't even rationalize them. So orchestration is the technology kind of word that is going to help you manage those 10 to the 10 things, right, when they're running around in your environment. Because there's no way that a human being can sit and map out exactly where different pieces of the application should go. When something fails, you don't want a human sitting there trying to make a decision about, should I fail it over to machine 1 or machine 3, right? There's just too many combinations. There's too many things to deal with. You want that to be automated, and you want to be able to give that infrastructure your desired state and say, please keep it like this, whether or not, Amazon wrote a paper a few years ago, and I forget exactly which one it was, but they had a really great line, which was, people should be able to put things in their shopping carts whenever network routes are flapping, hard disks are failing, or data centers are being destroyed by tornadoes. That's great. And that's orchestration, right? That's what it'll do for you. So orchestration is a complex space. This is an eye chart. I'm not putting it up there for you guys to actually have to digest, but there's all sorts of different capabilities that are all out there in all of the different orchestrators that are out there today. Some do some really good load balancing stuff. Some do some really good deployment and density stuff. Some give you some upgrade things. There's just a shed load of features in the orchestration space generally, but we're going to distill it down in some real problems that you guys probably actually have. We're going to talk about rules, which are kind of like the specific sort of please don't break these rules things that you need enforced in order for your services and applications to work correctly. We're going to talk about some optimizations, which is now that you have 100 machines and 10,000 workloads, you can't just have one machine dedicated to one workload or one application anymore. You want to pack them all in. You want to do it optimally. You want to manage the resources, things like disk and memory, to make sure that those applications perform well even when they're packed in this dense environment. And you want to make sure that those machines don't get overloaded at the same time. And we're going to talk about processes, and the best one is always rolling upgrades that we can do without downtime. So you can patch your code, change config, do any sort of manual interventions that you need to do, and not have to worry about uptime and things like that. So let's jump right in. Let's talk about some rules. So rules or constraints are kind of the general service fabric mechanism that we give you for doing some certain specific things, like mapping particular workloads to particular nodes, and there's some legitimate reasons why you still want to do that. Enforcing certain policies, like this workload cannot run in this region because of geopolitical concerns or something like that, and preventing some overloads, like this machine really only has this much hard drive space. If you try to put more things on it, they will fail because they're out of hard drive space. So let's talk about some of the basics. So fault domains. Okay, fundamentally, you want HA, right? You know that there are certain things that are going to happen, like this regional office, might have its power blink out separate from that regional office, right? That's the notion of a fault domain. It's areas of correlated simultaneous failure, right? These are pretty standard. You see them all over the place. Azure has them. If anybody has their own data centers or IT environments, you probably have them. Service Fabric lets you express these so that you can say, basically, here are my data centers, my racks, my blades, my individual machines, and we take care of when we create replicas, when we put things out into this environment, we stripe them so that no one core, one failure takes down the whole thing. And we do this automatically. In Azure, when you can stand up a Service Fabric cluster in Azure, we'll pull information from the Azure fault domain environment and just use it. If you're setting up these things on your own IT environment, you're going to have to give them to us, but basically, there's all sorts of ways to do that. So what does this look like? Well, next you get upgrade domains, right? Upgrade domains are the next thing, right? You usually want these as a matrix, right, striped across the fault domains. So now you can survive both one fault domain going down while you're in the middle of an upgrade, and you've still got your app running, which is pretty nice. And this is, again, something that we just kind of do automatically on your behalf. You can give us the information. We'll take care of placing things correctly. Again, this stuff is pretty standard so far. Makes sense. Okay. So what's next? What's next there in terms of rules? Well, we have these things called placement constraints. Placement constraints are basically you can tag nodes with arbitrary parameters, arbitrary key value pairs, and then when you create your services, when you create your workloads, you basically can write a simple Boolean expression, they're strings, right, to say this workload should only run in places where this is true and that is less than or equal to that or this other thing. Right, so you can come up with these expressions. They can be arbitrarily complex to select which nodes out of this giant cluster that you now have. And an example of that is kind of on the right there, which is, maybe in Azure, maybe in any other environment, you have kind of the notion of the DMZ, right, where all the incoming traffic gets terminated and then it turns into a lovely trusted subsystem. We know what's going on kind of world. So you want to have only the client terminating endpoints sitting on these machines, which are specifically, say, in Azure roles today, have their input endpoints, and then the other ones run on the other ones. So we let you select based on either arbitrary parameters, types of nodes. You can define your own, and when you create the service, you just give it that little expression, and we go and make sure that that doesn't happen. So imagine you took a node that was tagged one way, formatted it, brought it back up, as tagged some other way, and there were workloads on it. Now we know, those workloads don't match that machine. We move them out. So we do this sort of evaluation pretty much constantly within the cluster, to make sure that your rules stay enforced, and you can actually also update them on the fly in case you decide that various things have changed. Another kind of rule that we enforce in the cluster is the notion of capacity. An interesting thing about Service Fabric is that we have a very rich resource governance, resource balancer, which helps you pack all sorts of workloads onto the same machine, but also make sure that those machines don't get overloaded. The interesting thing about that is that I don't necessarily know what metrics, what resources on that machine are important to you. It might be network, latency. It might be your services work queue depth. It might be disk I/O. It might be whatever. So we let you actually express whatever resources you want. You can tell us about them. You can tell us how much you're consuming, and you can tell us how much that machine, that node, actually has to offer. And then when we're placing services or failing things over or moving things around, we make sure that we don't go over that limit, right? We know how much each little replica is consuming. We let you tell us. That can either be statically defined or dynamically updated during runtime, so it can spike and move with the course of the day. And we take care of ensuring that both when we need to put things somewhere and then during runtime, say a resource spikes, some guy starts consuming all the memory or something, right? We can do the right thing in order to ensure that that node is not overloaded, because overloaded nodes give poor performance characteristics to just about everybody. So we do, basic math. It's subtraction. It's not too bad. So placement policies. So this is where, when you start building really large Service Fabric clusters, you start having some really interesting scenarios around geographic distances, right? You literally have offices on the East Coast, the West Coast, and the South, or maybe you just want to service your customers there. And so you need a way to say, hey, since Service Fabric, you're doing all of this stateful service replication stuff, you're holding on to my state. And my users are all in, let's say, Boston. But by default, since I've built this one giant geographically spanned cluster, some of the replicas, in fact, the primary, which the guy needs to talk to all the time, is over in US West. So that's leading to latency spikes, and I don't like that. If you could just say that the preferred primary location is US East, we can go ahead and move the replicas around and ensure that that's true. And you can couple this with all the other rules, so it would only land on the non-DMZ nodes in US East, right? The next thing is you can say, hey, that data center is actually in a different geopolitical space. I manage them all as one big cluster for convenience, that I only have one cluster to talk to. But this workload actually shouldn't ever run in that DC South. So you can say that's an invalid domain for this workload. Other workloads might be fine. And you run these all in the same cluster. You can express these constraints, these limitations, these rules per workload, and we manage them all kind of simultaneously. So now we're going to switch to a demo, but I'm going to show you what I'm about to show you before I show it to you. Because even with small numbers of things, what exactly is going on can be a little bit hard to figure out. I refer to this thing a little bit sometimes as, if you remember from Hitchhiker's Guide to the Galaxy, the infinite improbability drive. So it kind of has to simulate things before it ever goes and touches your cluster. And therefore, sometimes it will do the thing. It will do exactly what you told it to do, but the path it takes to get there is opaque to us mortals, which is fine, right? So long as it enforces the rules, doesn't go over the constraints, doesn't break your load balancing, doesn't do anything else. I don't necessarily have to know. I don't have to be in the flow of decision making. I should be able to give it my requirements, my constraints, and let it act. So we're going to show you just default placement, right? So we're going to create a simple service. It's going to have 3 partitions, 3 replicas, so 9 things. I've got a little 9-node dev cluster set up on my box. And you're going to see, one thing on every node. But what we've actually done is I've got 3 fault domains, 3 nodes per fault domain. I've also got 3 upgrade domains. And we're going to see that actually I am balanced, and every individual partition is obeying all of these rules. And we do this kind of automatically. So let me make sure I get the right box here. I believe it's 7. Right. Okay. So this is what I've got. I've got that cluster set up. You can see it on the right. And what I'm going to do now is I'm actually going to add some additional constraints. I actually should have shown this to you. Sorry about that. So we're going to add some more constraints. We're going to add some rules. So it turns out I've gone and tagged all of the nodes with arbitrary tags. Who here knows egg freckles? That's an old joke. Go look Doonesbury egg freckles. You'll be fine. And core is something that makes a little bit more sense. So we got egg freckles or spots, and I'm going to say to this service, hey, you only want to exist on nodes where egg equals freckles. and cores is greater than or equal to 8, right? And we should see the services suck themselves onto a few machines. So let's go and do that. Okay, back here at the cluster viewer. Sorry about that. So you can see on the left now I've got the PowerShell set up. This is the update, Service Fabric service script, or it's just a PowerShell commandlet. You can put all sorts of stuff in here. You can change the replica set sizes. You can play all sorts of havoc. You can do all sorts of fun stuff. But we're going to use it to update the placement constraints. So I'm going to go ahead and run this, and we're going to see what happens if I have the right focus. There we go. Okay. Cool. So we're moving all the services off of those machines, and we're putting them onto the machines that match those constraints that we just specified. Now, something to note is that these are actually stateful services. So if I go over here to this workload, I'm going to use my data center for what we all use data centers for, which is counting words. And we can see that, yep, that's counting words, and I've got the replicas in place. And that last guy, okay, there he goes. So here we are. I updated the constraints. Now, I said, well, actually, that was kind of silly. Let's take those off. Let's put that back. Forget about that constraint. Please put it back the way it was. And what we'll do is now, while this workload is going, right, we're building more replicas. We're moving things around. And what we should start to see here is we'll get a whole bunch of new replicas in build. We're copying the state to those machines. We're promoting them into the replica sets. We're making sure that they are all caught up, and then we're distributing the load back around again. Right. So you can play with these constraints. You can turn them on. You can turn them off. You can update them on the fly, and you just let Service Fabric take care of enforcing those rules that you gave it. For the purposes of the demo later, I'm going to go ahead and turn those back on. It doesn't really matter that it's not done yet. It'll figure it out. So it's great to be able to just do these sorts of experiments, right? You can make certain decisions, you can make certain rules, you can update them, and then you watch the cluster kind of move itself into the desired state. We're going to let that run, and I'm going to switch back to the slides, and we're going to talk about some of the really interesting stuff. Okay, so next we're going to talk about optimizations. So now that you've got the ability to set up these very specific kind of rules that let you tag nodes and put workloads in certain places, you want to make sure that your cluster actually ends up balanced, right? You don't want it to just turn into giant lumps of hot nodes and cold nodes, right? You want to make sure that those are all spread out, because if workloads pile up on a machine, you end up with poor performance for the workloads that are running there. So that we give you a whole bunch of ways to do this. The default that we just do is we basically count the replicas, right? We say we're going to count the primaries, count the secondaries, count the total number of things, and we're going to make sure that no node has more of those things than anything else, right? We're just going to distribute it all out. So this is kind of what you get, right? You create a service, we count the primaries, we count the secondaries, we make sure that generally in this cluster, yep, that looks balanced. They've all got, no node has just stacked up on the primaries. All the nodes have about the same number of total things. The secondaries are all well balanced. This looks good. But it's very simple, right? It presumes that all of the primaries, all of the partitions, all of the different workloads are basically uniformly sized. And generally, that's never true, right? You get a hot workload, you get some partition of your database or something that's receiving an inordinate percentage of the requests. And so now you need to take that in consideration. So we give you the ability to add these sorts of custom metrics where you can say, hey, I actually also care about memory. I'm going to report my memory consumption. And I want you to take that into consideration and balance that, as well as those other default metrics. You can keep ours, you can not. You can have whatever combinations you want. You can take some of them. You can inject arbitrary numbers of your own. We have people that run with just crazy numbers of metrics. We have, I think, the largest one is probably like 200 or 300 distinct metrics that they're measuring in their cluster and letting them all be balanced and sorted out at the same time. So in this case, look, I've got memory balanced out, and I've got the primaries and the secondaries and the total number of things. It's all balanced out. It's pretty good. But you're saying to me, hey, Matt, memory is actually way more important to me than whatever the heck it is you guys are talking about. How do I tell you to prefer or select for certain metrics over the other ones? Now, this one's a bit of an eye chart, but basically you can tell us, hey, for each of these metrics that I have, here's how important they are. This one is very important. This one is high weighted. Weight this one high. If you're going to try to balance out the cluster and you can't get it perfect, prefer having this metric balanced, right? It's the one that's most important to me. And then you can have, high, medium, low, and basically I don't care are the 4 ranking levels. And so you can say, hey, in this world, if I said that metric A was the most important metric, I get this allocation where A is more balanced than B. And if I flip it around, which of course you can do, you get a slightly different allocation, right? And now that you're doing this on thousands of nodes, it's, you can see it having a real effect in terms of how the cluster gets laid out, right? But the main thing to think about is that you're not sitting here having to figure out how to direct traffic to particular places. You're not having to play sorts of games. You're just reporting what you're consuming, telling us about it, and telling us what's important to you, and we're taking care of ensuring that that allocation is balanced across the cluster. And as I said before, we try for perfect balance, but we all know that perfect balance is kind of an illusion. And we're going to spend a lot of time relaying out small imbalances, right, if we don't do something else. So we have this notion of a balancing threshold. It's basically, what's the ratio? How bad should we let it get between the maximally utilized node and the minimally utilized node before we spring into action, right? And so for your metrics, and then each one is independent, you can say, hey, for this metric, don't let it get beyond like 2.5, right? Or don't let it get beyond 3. This metric, I want it perfect. And only when things exceed those thresholds do we spring into action. So in the first example here, everything's fine, right? Max is 5, min is 2. That's below my ratio of 3 that I selected. Cluster is balanced. We're not going to touch it, right? We'll leave it alone. The bottom one, though, due to maybe failovers or maybe some machines just came in or left or something like that, a whole bunch of work has stacked up in a place, which can happen. Now you really want it to balance out because that's just too much. That's too much in a spot. So when we see this, we go, okay, we're going to take that and spread that back out, and now we know I've got 6 in one and 5 in the other, and that's 1.2, and I'm balanced again. And then I go back to sleep, and I wait for the next thing to happen. So this is good. There's another problem, though, which is sometimes your clusters are cold. Not always, but sometimes. Maybe you just added a whole bunch of nodes. Maybe you're just booting the thing up. And now we're saying, well, you've got a whole lot of stuff, and you're really imbalanced, but it's a small absolute problem. So we have this thing called the activity threshold, which is basically unless nobody's over this minimum bar, don't touch anything. Right? It's a gate on the balancing. So you can say, hey, the cluster's cold, do nothing. Right? Just let it sit there. It'll warm up later, and until then, you'd just be moving things around and not really accomplishing anything. So now that we're talking about moving things around and responding to failures and doing proactive balancing, you have an interesting problem, which is not everything is even though it might have different amounts of load that it's expressing, it might actually be small or it might actually be large. And since we're talking sometimes about stateful microservices, when we're talking about moving things to entirely new places, we're talking about copying all that state. If this is a 150 gigabyte SQL database, you don't necessarily want me just throwing it willy-nilly about the cluster, right? You'd kind of like it to stay still unless it absolutely has to move for some reason. So we have this notion of move cost, which is basically another hint into the resource balancer to say, hey, if you're trying to balance the cluster and you have a whole bunch of different solutions that are all about equally balanced, prefer the one with the fewest total number of moves. That's a good first gate. And then the second thing that you can do is we're going to actually tell you which of the things are heavy, expensive to move, and which ones are light, easy to move. So prefer the solution with the overall lowest cost. And again, you don't have to do this. We do some of this automatically, but you can give us all sorts of additional hints and data in case you see it being too active for certain types of workloads. Okay, so now we're going to look at what some of that looks like. So we got our cluster that's sitting in this state, and we're going to keep the placement constraints there. And what we're going to do is we're going to add a metric that we're going to. So let me back up. We're going to report some load, and what that's going to cause is all the primaries are going to conglomerate in one place because that's the only place that fits them. So you can see there's a capacity number that's actually on all these nodes, and we're going to go ahead and say, hey, the primaries consume 25, the secondaries consume 10. So the primaries can't actually fit anywhere except for that one node. And the secondaries also can't fit anywhere besides that other node. So we're going to see them flop around. And then we're going to take all that off, and we're going to watch the cluster go back to its gloriously distributed state. Let's see that happen. So let me switch back to this. Okay. We've got our cluster, which is balanced out. That guy is just a glitch. Okay. So we're going to talk about balancing. So here's the command. First of all, I'm going to just give it an arbitrary metric. We're just going to call this metric 1. Could be anything. You can create these and add them, remove them, update them on the fly, the set of metrics. But basically, each service could have its own entire different set of metrics. So we're going to say, by default, you have this metric. It's very important that it stay balanced. The primary is going to consume 10 by default, and the secondaries are going to consume 5 by default. So we go ahead and we update that. That's the new service description. It's got the metric tag there, so we can see that that actually has taken effect. But nothing's moved yet because those loads are actually fine. This layout is fine given that layout. So this service has a little web API on it, and I'm going to poke that API and tell it to report some load for metric 1, and then we're going to watch what it does. So let's go ahead and do that. And what we should see is all the primaries move down there to node 6. There we go. Okay, cool. So we've just done proactive load balancing, right? These things just got a whole bunch of load. They called an API that we, the system, give you in order to say, hey, my load has gone up for this particular resource. And the cluster reacted to those changed conditions, realized that the primaries didn't fit on the nodes that they were currently on, and swapped them over to node 6 where there was room. And that just happened automatically. You know, this could be all automated. I'm just poking it with a PowerShell script because I can. But you know, something like this could happen, you know, normally in production. But this is a really terrible state, right? We don't actually want our cluster like this. So we're going to go ahead and say, hey, why don't you go back to the default metrics of primary count and secondary count and stuff like that. And while you're at it, take off those constraints too. Those are bad. And so we'll see the replicas get built back up on the other nodes and transition there. And by the way, you know, I think still counting words. Good. Okay, there go the replicas, and those will get built back and caught back up. The primaries will get redistributed. You can see that starting to happen. And this is, again, all kind of automatic. So as you're just expressing your requirements. You're just expressing your load, the resources that you need, how balanced you want it. And the system, Service Fabric, is taking care of ensuring that the cluster meets those requirements. If you give us bogus requirements, by the way, if you create a service and you say, I want this only on green nodes, and we go look in the cluster and there are no green nodes, we won't let you even create that service, right? Because otherwise we'd accept it and then try to place it and nothing would match, and it looks like it's being created but nothing's really happening. So we have all sorts of diagnostics that say, hey, I'm trying to place these replicas, I can't place them on this machine, I can't place them over here. Statistically, it's probably because I eliminated all of the nodes trying to match this other constraint that you just set up. So if you put, say you type something in and you spell a parameter wrong, we'll actually leave it alone, right? We don't move it unless we can find a good place for it. We tend not to touch things unless we have to. And so we protect against this sort of stuff by saying, hey, all of this balance stuff is great, but HA, like availability, of my actual service trumps that, right? So if I can't find a solution that works, I'm just going to leave it alone, and I'm going to emit a whole bunch of diagnostic information telling you why I can't do what you asked me to do. But your service stays up and running. Okay, so let's go toggle back to this, and we can talk about kind of the last thing, and then we can get to questions and that sort of stuff. We're going to talk about some processes. So that was balance. So no downtime. Who likes no downtime rolling upgrades? Right? We all like those. Those are good. They mean I can push out things without having to worry about shutting out all my customers. But now you have an additional problem, which is you want to do that rolling upgrade. You have all of these capacities in place. You have all these different metrics. You have these placement constraints you're trying to enforce. And you don't want any of those things broken just because an upgrade is going on. But you really want that upgrade to be able to make progress and proceed through the cluster. So you want to keep the workloads optimized, even though you might be taking down whole sets of machines in order to patch some hardware or update some firmware, or in our case, when you're using Service Fabric to upgrade your code. So you want to maintain that availability and reliability without actually sacrificing any of the things that I've already talked about. So we like monitored rolling upgrades. Service Fabric actually has a very rich health monitoring thing built into it, where we know all sorts of things about your application. We have pretty good insight into, when these replicas are all moving around, are they taking a reasonable amount of time? Are they having problems opening? Is it this node that's the problem and everywhere else seems to be fine? We gather all this health information and we use that to inform these sorts of rollouts in the cluster. So if we start trying to do an upgrade and we take down the first upgrade domain, we pull down the new bits, start everything back up, and it never really starts back up. That upgrade freezes. It sits there for a while, hoping for things to become healthy. And then if it does not become healthy, the default policy is basically we can either throw up our hands and say, hey, administrator, something's broken. Tell us what to do. You haven't compromised availability yet, so it's fine to involve a human. Or you can just say, hey, I really need that X% of my cluster, that upgrade domain worth of machines. So just automatically roll that back. Just put the bits that work back on, start it back up, put everything back, and tell me that it failed and kind of why it failed. This health can actually also be extended by you. So if you have a Gomez monitoring thing or some other code maybe that you wrote yourself that's acting as a watchdog on your code, doing some synthetic transaction, making sure things still work, you can emit that health into the system and say, hey, here's the current health of my app. We take that into consideration right along with all of the automated stuff that we do on our own. And we use that to basically gate and check the rollouts of any upgrade. So if you get midway through the cluster and 20% of your applications are unhealthy, you can have a policy that says, hey, 20% of my applications are unhealthy, halt this thing, and give it this much time to stabilize, and if it doesn't stabilize, roll it back. So we can express all these sorts of things. So we make heavy use of that inside the orchestration layer to make sure that these sorts of upgrades go more or less unattended. So if you guys haven't heard this already, SQL does thousands of these upgrades like weekly. They just kick them all off, and they kick them all off in parallel. Most of them succeed. Some of them might fail because of a random glitch or a bug or something. They just roll back, and then they find out what the situation was, or maybe it was a transient error. They update it again, and it rolls out, and they push the state of all of the SQL databases into the desired state, and that's how they know. So another thing that we do give you, though, in the Azure environment, it won't be as critical, but if you do run these things on-premise, Service Fabric clusters on-premise, they might become necessary, which is the notion of these sorts of manual interventions. So you still want to go kind of say upgrade domain by upgrade domain, but let's say that you need to update the hardware. You need to swap out a drive that's failing or something like that. You want to do this, but you don't just want to yank the cord. I mean, you certainly could yank the cord, and we'll react to that actually fine. But usually you want it to be a little bit more graceful than that, right? Because you want to inform the system up front that these sorts of things are about to happen. So we basically give you graceful failure APIs to say, hey, I'm taking this machine out of rotation. Don't put any work here. Drain the work here that is out. When that's done, let me know. Then I can go pull the drive or do whatever else you need to do. And then when you're done, you can turn it back on. So those are such a thing. And kind of the last thing, which we've been showing you throughout the week, which is also really cool, is we have this notion of a chaos test service that you can target at your workloads, both in your test environments and in prod, because it's very safe. And it just kind of causes a low level of general faultiness to kind of be injected into the environment. And that helps you accelerate your testing so that you find the sorts of bugs that you're only going to find kind of like in production and in these complicated environments. You find them sooner. You find them on your dev box. And you fix them before they ever make it into prod. So all of these things are kind of processes that Service Fabric exposes that we let you kind of use and leverage. And we're gonna show you some of those now. So I've got the cluster. It's kind of laid out. I'm going to add a constraint there, cores greater than 3, to kind of eliminate just a couple nodes. That's a rule. I don't want to see that rule broken. And then we're going to do an upgrade. Now I'm going to do some manual failures first, just to show you how those work. One thing to note is that when we do upgrades, we kind of take down the machine first, right? Which means we want to move those workloads out, do the patch, whatever it is, and then turn them back on and watch the workloads come back. We actually also support 2 different kinds of upgrades. So upgrades that touch code, I need to shut down the process because we need to start up the new process with the new code inside of it. But there are other types of upgrades too, like things that just touch config. And so we're going to actually I'm going to show you the manual one, which is going to deal with the persistent services. And then we're going to do a no downtime rolling config-only upgrade where your code never even restarts. It just gets the new value. And we can show you that working. And those are good to have because now you can do versioned config rollouts. And they're all subject to all of the same health and safety checks, right? But you're not actually even shutting down the process, right? If you're just going to your config and pulling if your code just goes config and pulls the data back, all of a sudden that data will be new and you'll get the new value and everything will work pretty much spectacularly. Okay, so we're gonna do some manual things, and then we're going to do a config-only upgrade. We're going to watch it roll through the cluster and see nothing happen except for the value change, which is actually pretty great. Okay, so we're back to this thing. Looks like I've got things laid out here again. We're going to go ahead and we're going to find the nodes where the primaries are, and we're going to kill them because that's fun, right? We're just going to whack 3 nodes. So we're going to find the primaries. It looks like we got node 8. And we'll see the status code there flipped to 2, which is down. I didn't have enough time to do a fancy animation for down nodes. I apologize. But we see that the workload is in fact down now. Now, since that's a persistent replica, it's got all of its state still there. The node's down. It's not gone, right? It's not on fire. It's just not connected right now. So we know that that state still exists. And if I bring this node back, it's going to be able to pick up from where it left off because these are persistent stateful services. But meanwhile, I'm failing over the primaries, right? I'm making sure that they go somewhere sensible. Did we get the third one? There it goes. Okay, so now I've taken down those 3 nodes. Let's see. Yep, still counting words. Good. Okay, so, outage is been handled. Let's go ahead and start those nodes back up, and we'll watch them put the replicas back. There's no guarantee, by the way, that the primaries move back to where they were, because now they're the most up-to-date copies of the state. But you should see the workloads get redistributed again as these nodes blink back online. So there we go. There's one, and we'll get the other 2 in a second here. So this is all good. This is like normal failure. This is life. You got some rules. You got a couple metrics. You got a couple constraints that you want enforced. But now we're going to do, the thing that is usually and kind of is historically the white knuckle stuff, which is the upgrades, right? We're just going to kick this off, and we're going to watch what happens. But first, just to make sure that we're stressing the system appropriately, we're going to eliminate nodes 3 and 4 with displacement constraint. So I have to move the replicas off of there and shut them down and flop the primaries over and build spares, because you told me you wanted 3. So I'm going to make sure that there's 3. Everything else, being equal. Okay, that looks good. Now I've got another little web API on this service that's I'm going to go ask it for a value for a particular configuration thing. Ooh, that's cool. I didn't wait long enough. Load server returned to 500. Well, we'll skip that part. You would have seen a really great joke involving the number 42, which is kind of a shame that we don't get to see that one. But so what it was going to do was, I didn't give it enough time for the address to propagate, which is my fault. It would have gone to the service and said, hey, go read this config value from your package, and it would return 41 as the value of the config parameter meaning, which we know is incorrect. So now we're going to do that upgrade, and we should, at the end of that, have the correct value for the property meaning. So we're going to watch the upgrade go through here. Now, you won't see anything on the actual cluster viewer because we're not shutting down the code. So the replicas are staying right where they are. We're grabbing the new config value from a package that we created. We're pushing that out into the cluster, upgrade domain by upgrade domain, and you can see the status of which ones it's done and which ones it isn't. And then when that's done, we're going to give it a few more seconds, and then we're going to try resolving that address again, and we should get the correct value back. So it looks like we're almost done with the walk here. Okay, all 3. Good. Let's be patient. Let's be kind. And let's go call that API. And there it is. Meaning is 42. Right. Okay. So that was 41 before. You're just going to have to trust me, unfortunately. But that was a config, no downtime, rolling upgrade. If that had somehow, broken the entire service, it never would have made it past the first upgrade domain because they never would have come back. So even if it's a no downtime one, say you're polling this property constantly to go do something else, if that starts causing the replicas to explode, report fault, have various exceptions, those replicas would have gone down. We would have seen that for sure in the cluster viewer, and then the upgrade would have stopped, halted, rolled back, and we would be back at 41, which would have been wrong. So cool. So now we've got these placement constraints. We're going to take those off. And we're going to invoke some chaos. Invoking chaos is one of the things that the Service Fabric team loves to do because it proves that most of this stuff works. And so I'm just going to run another PowerShell. Everything today has been PowerShell except for the APIs that I've gone and hit on the actual service. So I'm just going to start up our chaos PowerShell commandlet, and I'm going to launch that in another window so that you can see it doing stuff. Just before anybody calls me on it, I also took the constraint off. So node 3 and 4 are valid. It should maybe move some things there. But now chaos is just kind of stepping in, and it's doing things like killing random replicas and shutting down nodes and trying to move replicas to particular places that may or may not be valid. And it's just going to go through there. And it's a low level of fuzz in the cluster or churn in the cluster, just to prove that all of this stuff kind of works. And it's fun to watch. You like high availability technologies, I guess. So there we go. We're going to leave that. We're going to go back and finish up a little bit with the slides. And we're going to come back and we're going to see that it's still counting words and stuff like that. So here's the good idea. Here's the neat part. This is the service orchestration technology from Microsoft. This was the eye chart of features that I showed you at the beginning. The green ones are the ones we have. The white ones are the ones I don't think are important or don't pertain to us relative to other cluster orchestrators out there. Something to note is that the word orchestration today is usually coupled tightly with the word containers, and that's not true. It's common. It makes all sorts of sense. But they're different things. Orchestration is just about ensuring that all of these things work and happen. But it doesn't necessarily have to be containers that you're orchestrating. As we've seen here, it's microservices, which are basically just processes. In Windows, those could be job objects. They will be Windows containers as the Windows container stuff comes along. When we move this to Linux, they will become Docker containers. It doesn't really matter what you're orchestrating. But the cool thing about orchestrators that have insight into the applications, which these ones do, is that stuff like they're reporting how much load they're consuming, right, in real time. It's not a static number that's just kind of set once. But you can still, of course, set them statically and just let them get laid out. So orchestration is this rich space with a whole bunch of stuff that you can apply to basically any workload. And with Service Fabric, you can apply it to any workload, on-prem, in the cloud, different OSs once we get there. All this sort of stuff just kind of works, and it's actually remarkably fully featured. It is a superset of a lot of the other orchestrators out there. Once I'm off mic, we can go talk about some of those other orchestrators, and I can tell you some of the comparison points. But this is the sort of thing, that's an XKCD comic, which is the kind of human I am. Remember the number 350, go check it out later. So in conclusion, right, so Service Fabric is a state-of-the-art orchestration engine. It does all of the things that I've shown you today. It does a whole bunch of things that I didn't show you today. It is very fully featured. It can solve most of the problems. Again, we use this thing realistically inside Microsoft to run tons of different services with all sorts of different requirements. Service Fabric enables DevOps. As we've seen here, I'm just doing stuff on my dev box. This is a 9-node environment that I set up. I'm running chaos. I'm trying different placement constraints. I'm playing with the metrics. I'm seeing what the balance is. I would be running perf tests, right, to see if the metric allocations, if they follow some curve, whether or not it works the way I expect it to. We handle a lot of things automatically, right? We do things like fault domains, upgrade domains, basic metric balancing, all this stuff by default. You don't necessarily even have to touch it. Right? But if you do touch it, you can go do all sorts of advanced scenarios that are going to be specific to your workload. We've kind of tried to set the baseline at stuff that's going to be applicable to your work regardless of what type of workload it is. But there's all sorts of other things that you can go leverage. There's, as I said, there's lots of features that we didn't talk about today. Some of them are a bit more prosaic, but they're all there, and they're used widely inside of Microsoft today, and hopefully in your guys' environments soon. And Service Fabric has been around for a while. As I said, I've been working on it for about 5 years. Turns out that's not as long as even some of the guys on the team have been working on it. So we're proud that it can do all this stuff. We're very happy that it's this feature-rich, and we're very, very, very excited to be able to get it out there for you guys so that you don't have to go deal with that mishmash of stuff that I kind of showed at the beginning and try to figure this out on your own. We've already gone and done the work. We're pretty sure it works. It works really well, as a matter of fact. And we're glad to be able to give it out to you guys to use in your environment, so you don't have to solve this stuff. That's pretty much it. Call to action. Thank you. Call to action. I'll be here for questions because we have some time. Call to action. There's an SDK out there. It's exactly what I'm using on this box. You can go get it, play with it. There's tutorials and videos. There's docs. Provide feedback. There's a feedback about the product is going to be at these links. We have forums. There's a tag on Stack Overflow. There's all sorts of things that didn't exist 2 weeks ago, which is amazing. I have a Twitter. It's weird. It's weird after not being able to talk about something for 5 or 6 years to be able to tweet at people about it. It feels very odd. And there are other sessions. Most of them have already happened. There's one more today on the actor model, the director's cut, which Vipul, who's sitting right there, will be giving a little bit later today. Watch the other videos. We also had sessions at Build. There's sessions there. Mark Rasinovich gave a demo of some of this stuff, which is pretty cool. Go play with it. And when you get a chance, scan this QR code, I guess, and talk to us about how the session was, whether or not you liked it, whether or not I talk fast enough, things like that. And that's pretty much it. I'm going to leave us there because that's the good stuff. Okay. Questions? There's mics, which they've asked me to ask you to use. Your shout? Okay, and then I'm going to repeat you.
What's the roadmap for this?
What is the roadmap for this? So the SDK is available now. We hope to be in public preview in Azure, certainly by the end of the year. That's our current estimate. And that environment will basically be, you can go up to Azure, you can go up to the new portal, you can request a cluster of kind of arbitrary size and configuration. We will stand it up and configure it for you, and then you basically get the environment that you've seen here, which is it's standing up there and ready. You can put your services into it, deploy them, upgrade, play with them. As of today, it's only on your dev box, but with the stuff we've given you, there's plenty of stuff to do on your dev box that hopefully will tide you over until the Azure preview environment gets up and running. For on-prem story, this will be delivered as a part of Server 2016. It'll probably be a feature there. And we'll work out what that means as the server plans land. But it's going to be in both environments, Azure and on-prem. And some people will need it in one versus the other based on, say, geopolitical requirements or other stuff like that. Next question? I'll give the guy at the mic a shot just to encourage the rest of you.
A couple questions. First, on the operating system, is it managed by Microsoft? Is this is a PaaS offering, so you're managing the OS, doing updates to the OS, or is the customer?
So for the Azure environment, it will be a PaaS environment in the sense that we will help manage as the OS, but it will be the new IaaS stuff. Basically, Service Fabric will work as an extension on top of the new IaaS model that's coming in the world today. We talk about PaaS v1, which is kind of the web and worker roles that exist today. And then there's IaaS VMs like that, and there was this kind of interesting separation between the two. In Azure, when we say PaaS v next, what's going to happen is we're going to have a much different and better IaaS offering where you'll be able to inject arbitrary runtimes. So you could have an extension that does, say, Chef or Puppet. You could run that as an extension. When you stand up the IaaS VM, that extension gets installed, and then you can interact with that extension or whatever your dependencies are on it. In that world, Service Fabric will just be another extension. It'll be one of the primary ones, but you'll be able to select it. And then you have effectively your IaaS machines that then will have our runtime running inside of them.
So the idea of like a PaaS worker or web roles kind of going away, I guess people
it's not going away. Like PaaS v1 is very well established. Lots of people use it. It's going to be in existence for quite some time. We're just saying that this is the next level. So those that want to move or can move or are writing net new stuff or want to lift and shift a little bit easier than maybe they have today will have that opportunity. But the existing stuff isn't going away anytime soon.
One other question. We've had some issues when we're doing upgrades, like so we're using web roles. We've done some upgrades to configure the software, and the worker role wouldn't get shut down to the right state. Yeah. And after like 30 minutes, it would move on to the next box, and that's kind of burned us. So it looks like there's some features here to kind of help prevent that from happening.
So one of the main things is that in Service Fabric, we strongly decouple your application, your code. From the machine. So to update that little config setting is not going to require rebooting the VM anymore. We also handle the safety of that walkthrough. It's not an Azure kind of infrastructure upgrade anymore. That was because previously everything was kind of in this one VM image, right, that got created. That's decoupled now, right? So the machines are up and running. Your workload is running on top of them, and then Service Fabric manages that rollout so that if things go wrong, as you mentioned, you don't get burned. It just goes back.
Okay. One more question, if I could, please. So let's say if you have many nodes and you're trying to do a config upgrade or software upgrade, and it takes some time, right?
Yep.
So you might have a mismatch in code between the nodes.
Yep.
So the ones that are getting upgraded, can they be like in a wait state until all of them are, or how is that handled?
I mean, you could do that, but generally you shouldn't want to. And the reason is kind of that you want these things to be rolling, right? So you have to do this sort of version compatibility thing, which helps you maintain that uptime, right? So if machine, gets unplugged and put in a closet for a year and gets turned on and plugged back in, you want it to be able to basically recover from where it is. Now, you can always tell us hey, that state's garbage, throw it away, and build me from scratch, build me from whoever's currently the leader or from whatever the standard is at this point in time. But that's a lot more costly, right? It also doesn't help you do these sorts of rolling things because, as you said, you're basically just going to be removing capacity from your cluster until you get to some tipping point, and then you hope it tips over correctly. And so you're not actually even testing the workloads that you've upgraded, right? So one of the things about this is I want work to start happening on the upgraded bits as quickly as possible, because that way if there's any problem, you haven't paved 90% of the cluster with new bits, and then only to find out that they don't work, right? So you want to catch that early, which means that you do need that version compatibility where things are going to end up talking to each other. You can do things like, you can try to do things like directing traffic to certain versions, but that's more of an A/B test thing. The way that we think about that, or if you're thinking about, how do I stage this upgrade? How do I stage this rollout? So to make sure that it actually works before I go do what SQL does and just, start it on 10,000 simultaneously. Basically, each application instance, I didn't talk a lot about the application instancing model, but there was a talk that you can go find that does talk about it. They're all independent, right? And so if you have 100 different application instances, you can upgrade one of them, right? And make sure that it works, right? And that's A/B testing kind of thing, right? You can watch it, it's receiving traffic, it's doing fine. And then once you're pretty sure that one looks good, or maybe you've upgraded a subset of your customers to the new bits, once you're pretty sure that works, then you can roll out the rest. But generally, we expect that these are rolling, version compatible upgrades. And so when you do have breaking changes, because occasionally data formats and other things like that do change, it's it's easy to see how that fits into a rolling model, because you can do things like, add the new field in and make sure it's nullable is kind of the mental model for it, right? So that when the old calls show up at the new bits, they don't freak out, right? And that way you can roll these sorts of breaking changes through the cluster, right, in a reasonable way. It just takes a few iterations, but the iterations are quick and cheap, so it's not as much of an arduous task as it used to be. Does that help? Okay. Other questions? Sure.
So, just kind of want to understand exactly kind of what's going on. We're injecting metrics, and are you running like kind of a linear optimization
nope.
on the metrics or something?
I'm just putting chaos back up because it's fun. If you really want to know what it's doing, basically it's trying like hell to minimize the average standard deviation of each metric load on each node in the cluster. Okay. But it also has to take into consideration all of those rules. So like say you've filtered out a node because it doesn't match some constraints. Well, that one's always going to have 0 of that load on it, right? Okay. So you have to play all sorts of games where you're not trying to examine every single possible option, because if you examine every single possible option, it's the heat death of the universe, and this is the knapsack problem and all of that good stuff, where you'll never find the right answers, right? You'll just never get there. So it takes a whole bunch of very interesting shortcuts to randomly try to pick solutions that work, evaluate them, make sure that they don't violate any of the rules, and then has kind of a scoring thing that determines whether or not this allocation, this layout of things in the cluster is better than the one it had when it started. So it's possible that you find a perfectly valid solution that's no better than what you had before.
Okay.
So why go through shuffling all the replicas? Just leave it alone.
So is it like a gradient descent?
Yeah, that sort of thing.
And
with a whole bunch of shortcuts because you don't want to get stuck in the local optimas, right? Because you have to hop across the gaps. And it's a multi-dimensional gradient, so it gets really kind of fun. We can talk more about it.
Okay, and then it sounds like it falls back, like if you have no solution or it's not finding something.
It just doesn't touch
things.
things.
It's like a fallback. Type.
Just sits. It just sits where it is. It didn't find a better place, right? So, there might be a better spot over here. Usually we can find those because we jump across the gaps. But in case it doesn't find this, or it jumps and then doesn't manage to crawl up any better, it just stays where it is. So it's all kind of simulation before it goes and does anything in the cluster. It's very rigorous about not making anything worse, right? I don't want to go through all this churn and all this movement and all of this work for a solution that, say, doesn't respect a rule or isn't actually any better balanced than what it was before, including, your limits, right? So you need it, if it's not even over 3-to-1 ratio or whatever you tell us to pay attention to, we don't even start, right? We don't even wake up and try and do anything until that trigger is met. So there's all sorts of gatekeeping that it does in order to filter out invalid answers, jump over local pits of things that don't work, and be sure that your cluster ends up in a better state than when it started.
Okay, cool. Thank you.
No problem. Any other questions? We got one.
So, a real basic question:
Sure.
How are you accessing the machines? What is that? Is that certificate? Is that identity?
Well,
Okay.
so security is kind of baked into the platform, so you can pick. In some environments, people don't have AD. There we primarily see certs. That's the main way that we expect people to do things. And in Azure with Key Vault, that's actually pretty easy now. So you can, for example, when you're connecting to the cluster, there's all sorts of different certs that you can use. Basically, you can say whether or not I'm an administrator or I'm just a kind of read-only user. Read-only user gives you everything that UI would need in order to kind of display the current state of things and tell me what's going on with health and metrics and stuff like that. The administrator things would be like creating new workloads, deleting existing workloads, manually moving things around, stuff like that.
So is it an agent that's on the box or
no? Yeah. So the Service Fabric has a runtime agent that sits on every machine, and then basically you're talking to that. So either your local code is talking to that when it's reporting its load or its health or stuff like that, or these administrative APIs which you're accessing through PowerShell or REST or whatever. You're talking to that agent as well.
Okay. And last question: you mentioned on-prem.
Mm-hmm.
Is that part of System Center? Is it standalone, or is it?
It's going to be a part of the. So there's kind of two things that are currently being discussed, and you can go and look more into them. So there's the new Azure Stack stuff. So Service Fabric is expected to be associated with that. But fundamentally, we are just a feature of Windows that's coming in Server 2016.
Okay.
You can use things, and so we've seen people do things like, I get a System Center Virtual Machine Manager template, right, that sets up the runtime, right, and configures things kind of on my behalf. And then you do System Center Virtual Machine Manager to stand up 11 VMs that all have the runtime and it's all configured correctly.
But this SDK, you'll be able to run it without having to...
Yeah, I mean, I'm running 9 nodes simulated on my local box.
It's not through Orchestrator, through System Center, it's a standalone feature that
Yeah.
really mapped out.
Yeah.
Okay.
So you can think about it, so just like with Azure, Service Fabric, I don't really care where the OS comes from, right? So if System Center is standing it up, or Azure is standing it up, or your IT department is standing it up on bare metal, all of these are fine. If it's VMware doing the hypervisor, we don't care. I just need OS instances. I kind of need to know the fault domains and upgrade domains you want us to enforce. And after that, you're talking to the Service Fabric runtime itself.
Thanks.
Yep.
Stupid question. Is this very similar, or have we already seen this in currently released pieces of software? I feel like I've seen this in Link before.
You have seen parts of it in Link. So this stuff has actually, again, been around for years at this point. Link, if you go look in the Link architecture, you'll find a box, usually labeled something like Magic Box, that does all the HA. And what is that thing? And what is all this goop on my machine? So that's us. We've been in Link 2013. for quite some time now. And that's why Link 2013 has the notion of this pool. That pool is actually one of these clusters. It has the notions of like primaries and secondaries. Those are these primaries and secondaries, stateful, persisted, replicated services. So we've been kind of leaking through the abstractions in a few places. Link is one good example, on-prem especially. Other places, SQL has always had this notion of like primaries and masters and replicas and stuff like that. This technology grew up kind of inside of SQL, so there's a lot of terminology similarities there as well. But yeah, if you've seen something labeled something like primaries and secondaries in Link, that's actually us. That's the runtime under the hood. Again, fun to be able to finally talk about this sort of stuff, right? No question. Sure.
So just kind of related to the metrics and feedback and things like that, have you guys talked about kind of like an application like handing you the metrics and Azure kind of like looking at those and trying to throw compute at it to kind of you know what I mean, to kind of optimize
so the set
based
of metrics,
on what metrics you kind of give and that kind of thing?
Yep. I mean, so that's what you would do on kind of your dev box kind of initially is you might be reporting certain metrics and you're saying, oh, I'm getting, so we get people that have done things like they take a kind of historical record of their load. So Link's actually a fun example. They have the 9 o'clock bump, right, per time zone for Link Online, where all of a sudden the load goes because, a whole bunch of people just show up at the office. And so you can do things like if you have that sort of load replay capability, you can get it on your one box, play your load back into your workload, and observe that the cluster does what you want it to do. You can then play, tweak, update your metrics in the scripts that I was showing you. I'm updating the metric sets, I'm changing the metrics, I'm updating their weights, I'm updating their default values, I'm adding and removing constraints, I'm doing all sorts of stuff. So you can absolutely play with it kind of in a sandbox, get something that you think works better, right, based on data, and then you can go ahead and just go do that update in prod, and the world gets slightly better balanced, and your performance gets better, and stuff like that.
Have you guys discussed like maybe feeding it through machine learning to kind of
we have discussed that,
and let Azure kind of figure it out?
Yeah, we haven't done that yet, but that's certainly an application of ML that I would think would be targeted at this area. Like you could totally do something like that. We also see ML being applied to, one thing I didn't talk a lot about here is we give you a pretty rich diagnostics environment where you can emit your traces and collect them and go look at them. But emitting them, we'll take them into this one ETW channel and go throw it up, and you could easily then go and throw it into Azure and throw it into ML. So you have both a record of it in, say, Blob or Table Store, but you also have learning to see the kind of things that are happening in your cluster without you necessarily having to have had to manually identify that pattern yourself. And then, of course, you could drive that back into metric weights and additional metrics and stuff like that.
Cool. Very cool. Thank you.
Yep.
So we can scale on demand, right, with this solution?
Yeah, subject to the hardware. So so I will, if you're running on-prem and you've got 10 physical boxes, right, and that's your cluster, if you start getting up to 90% utilization on those boxes, you have to go get another box and plug it in. In Azure, another VM has to get spun up.
So who's spinning up that VM?
So Azure Autoscale, for example, would do it, right? Or some guy watching the output.
And that OS would come from the gallery?
Yeah, it's exactly. So if you go look at Azure Autoscale now, like how it works, you basically set thresholds for certain things that it knows how to measure, like CPU and memory. And you can say, hey, if I'm over this percentage of CPU for this amount of time, please spin up that many more machines, right? And then it starts to do that. So you can set that at a predictive spot where if it's staying over this ratio for this amount of time, I probably want more actual resources. Those machines will get spun up. As we said, our extension will get installed. They'll come in knowing that they're a part of the cluster. They'll join the cluster automatically, and then the workloads auto-scale themselves out. You don't even have to touch your workload itself. It's all about when do you need more resources. Because again, we pull apart the pool of resources, which are the OS instances, right, from your workload. So when I was taking down machines and then adding them back in, the workloads just moved around. If you were adding new machines entirely into the cluster, same thing would happen. The workloads would get auto-scaled out. Okay. So you really only have to worry about, is my cluster running hot, like in aggregate, right? And there's actually more PowerShell and other APIs that you can use to say, I have this list of 100 metrics, here's how much is actually being consumed in the cluster for each of them, right? So you can have sorts of reporting and warnings to say, hey, metric 3, which is memory, is 75% utilized in the entire cluster. There's only 25% of the memory in all of these machines left. We can still do plenty of good work with that, right? If things fail over, there's enough headroom to be able to create all the spares and stuff like this. But you might want to go think about adding more machines. So you can tie that into Azure Autoscale or other things that are automatically spinning up machines, maybe like System Center or Virtual Machine Manager, and get the machines ready, and just the workloads will then scale out as soon as they join in the cluster.
Okay, thank you.
Yep.
I tried to ask this question 2 days ago in a different session, so I'm hoping maybe you can clarify it because I didn't understand still. Can you speak a little bit about how this relates with Project Orleans? I understand that to be an application architecture for highly distributed, highly available systems, and
Yeah.
this is more of at a system level, but can you kind of talk, are they intended to work together, completely distinct?
So Orleans is a specific programming model and a runtime that lets you write stateless actors. And then they give you a mechanism for persisting that state if you need to somewhere. And so there's plugins for things like Blob Store and stuff like that. But that's the Orleans architecture. Orleans on its own doesn't have things like upgrade. So how do you do a rolling upgrade with just Orleans? I don't know. I mean, I'm not an Orleans expert by any means, but it seems like it's more of the old, you have to kind of what?
It's a VIP swap.
It's a VIP swap. Okay, because it's stateless, right?
There's no orchestration, there is no load balancing.
Right.
All of the platform features that you see here, none of it are on Orleans.
Right. So the main thing is that it's a programming model. I mean, so it gives you that stateless actor programming model, which is fine. If you go look at, actually, if you attend Vipul's talk later today, he's going to talk about the actor model. Yeah,
Okay,
the actor model that exists on top of Service Fabric, which is very Orleans inspired, right?
Okay.
We did a lot of the same things because they were good ideas. And so the programming model, if you have Orleans code today, to port it on top of the actor model on top of Service Fabric is not that big of a deal. Okay. Now, there's another thing that you could do, which is what some of the Orleans guys are suggesting, which is, hey, take the Orleans runtime and use that as a Service Fabric application so that you get some of the platform features, but you don't have to really change your Orleans code at all.
Yeah, so you get that baked into the app, but then you're able to take care
but
of the orchestration on top.
I haven't seen it done.
Okay.
I'll put it that way.
Okay.
And you're going to miss out on some of the platform features that we think are very important and good because we lose some of the insight into your application. So your application, your Orleans type, is not a Service Fabric service, just the container is, the silo is, not the grains.
Right,
and
right.
so I don't have, for example, the notion of how much load a particular grain is having, or I don't know about its health. That sort of stuff you lose.
Okay.
You still can't upgrade. You still can't say that I want X type of grains to be available on U nodes or Y type of grains to be available on this node. So it is, you will lose a lot of the platform capability. The reason we did this, the active programming model on top of Service Fabric, is to make sure that you basically get a very high fidelity platform richness through the Orleans programming model.
Yeah.
Okay.
So you get the same programming model. I mean, so we frequently have people port their code from Orleans to this, and it's like a one-day kind of exercise.
Okay.
They're not significantly different in any way. And we did that intentionally to aid that sort of thing because we want people to be able to get the benefits of the platform, but not have to give up on that actor programming model. And so your actors, you don't have to use the stateful stuff. They're still, they're in memory only, or they're not even replicated. They're completely stateless. So all of that pattern still exists, but we think that the value that the platform provides is probably worth the rewrite, even though it's not that much of a rewrite. It's namespaces and a couple things.
Right. Great.
We can look at more differences, and I'll point out more stuff where we are different in the active programming.
Yeah.
Okay. Great.
Yeah.
Thanks.
Go to his talk. He's the expert.
Great. Much more clear now. Thanks.
Okay. Thank you. Any other questions? Okay. Thank you, everybody.